Hey guys, doing a little science here. I know I'm not the techiest person. I'm sure I could do a share screen thing, but I'm just videotaping what's up on the board here, just like you and I were all taking notes during science class with the PowerPoint presentation. So as of today, we're going to be talking about temperature and humidity and clouds and so on. So we talked earlier about how warmer air can hold more moisture than colder air. Those molecules are moving in a way they're juggling that water vapor, and anytime that water vapor slows down, it naturally wants to cling and make little water droplets. And then you see the mist, the fog, cloud, and if it gets even more and more, then it'll rain. So right here, humidity, moisture in the air in the form of gas called water vapor. Relative humidity is the percent amount of moisture in the air that the air can hold. Well, if the air is warm, it's going to be able to hold more. It's almost like if it's warm, it's a big bucket and it can hold more water vapor. If it's cold, it's like it's a small bucket. And that way, if there's a little bit more water vapor, it's just going to fall out, it's going to overflow, it's going to essentially rain. So the percent relative humidity is how humid the air is according to how much it can hold. And it can always hold more when it's warm, less if it's cool. After this slide, you'll see what I'm talking about. Warmer air holds more, colder air holds less. Relative humidity changes percent if the temperature changes. So let's say that you have a 5-gallon bucket full of water, and that's considered your warm air. Now, if you all of a sudden made the air cooler, that bucket gets smaller. So the same amount of water is in that 5-gallon bucket, it was half full, but if that's not a 5-gallon bucket anymore, if it's a smaller bucket, well then that amount of water is like 75%, 80%, 90%, because it seems like it's a smaller bucket if it's a colder amount of air. Dew point, the temperature at which H2O, water molecules, condense and precipitate. So if I'm looking outside and it's not raining, and all of a sudden it changes temperature, gets a little bit cooler, or more water vapors in the air, and all of a sudden it starts to rain, we say it has reached the dew point. Okay, so I have a little bit of a visual that might help you out. In this case, we'll say that that big bucket represents 95 degrees at 15% relative humidity. So not very much moisture. But the moisture, if you'll notice, won't change. But warmer air represents a bigger bucket. Now all of a sudden it cools to 75 degrees. Now that percent relative humidity is higher. 65 degrees, 55 degrees. Notice the water amount isn't changing, but the percent relative to how big the container is now changing. At 45 degrees, we're at 80%. At 35 degrees, we're at 99.9%. And we just dropped 1 degree and we overflow. And we would call that the dew point. The dew point. Okay? Hopefully that cleared things up. Clouds and precipitation. So the next phase of notes here is how clouds form. Warm, moist air rises. So when the warm air is down here, you don't see it as a cloud. But when it goes up, it cools, and those little water vapors condense and make little droplets and form a cloud. The cold air can't hold as much moisture because it's slow and they condense. So moisture condenses and latches onto tiny little particles of salt and dust in the air, and they form droplets. So they don't just condense on each other, they find little pieces of dust or things in the air, and there's so much of that you don't even realize. You breathe it in all the time, but it doesn't affect you. Droplets are so tiny and light that they float, especially since warm air is always rising. It's almost kind of like you always have sort of one of those hair dryers pointing up, keeping those clouds up. A collection of millions of these is called a cloud. They can be freezing, so sometimes these clouds just could be frozen little droplets. Now if we move on and talk about clouds specifically, you're going to be doing a little cloud project on a big piece of paper that I'm sending home today when you see this, Friday. And if you'll notice, I've got this split up into 3 layers, the low, middle, and the high. And you see some common themes here. If it's a chunky cloud, we call it cumulus. If it's flat, we say stratus flatus. Flat stratus, chunky cumulus. Here's a combination, stratocumulus. Here is stratus, that's just flat. Okay, this one here, the word nimbo means rain. So rainy flat cloud. Here you have altocumulus, so chunky, but in the alto. If you ever inquire, the highest is soprano and then alto is lower, but sort of in the middle. So we call this whole section alto. So altocumulus, chunky, alto stratus flatus. Cirrus, that's wispy. Cirrocumulus, so a little bit of chunk to it, just like this one, and a little bit of chunk in that one. And then cirrostratus, so that's really high as cirrus, and it's got flatness to it. Okay, so here again, stratus flat, it's low, so there's no prefix in front of it. But if you go up a little bit, altostratus, cirrostratus. Now we don't have just a regular cumulus, which, oh here it is, right over here. Cumulus, it should be over here probably. The cumulus is just chunky low, and then altocumulus, and then cirrocumulus. And then the outliers are combinations, strato and cumulus, nimbostratus with the rain, cirrus, real wispy. Now we get into the big sucker. This is the one that indicates some sort of storm. Because what you have is you have a rushing bunch of warm, moist air going up and a bunch of cool air replacing it coming down. So you have this action going, okay? And just like if you're sloughing your feet across the carpet on a cold day, you develop some static electricity and then you get the lightning bolts and so on, okay? We have a project for you to use cotton balls and make your own cloud project. So look for that.